Thrashing is a special type of memory trap that can cause performance-degrading damage in one's system. It occurs in a virtual memory system when a computer spends more time swapping pieces of a program between physical RAM and the disk than it does executing actual instructions, wasting precious time and valuable CPU power. Essentially, the system gets stuck in a loop of continuously moving data back and forth, causing useful work to grind to a near-total halt. When it comes to thrashing, there are 4 key characteristics that we should take note of, one of which is excessive page faults. It happens when processes frequently attempt to access memory addresses that are not currently loaded into physical memory, resulting in a continuous loop of page faults and disk read requests. Next, the system will slow down drastically due to the fact reading from and writing to a disk is significantly slower than accessing RAM. Even though the computer feels incredibly slow, the CPU is actually underutilized because it is constantly idling, waiting for disk I/O operations to finish. And last but not least, the system and application may freeze up, lag, or become completely unresponsive due to the relentless disk activity. Thrashing can be caused by a multitude of reasons. One of the most obvious reasons is when there is insufficient RAM. There simply is not enough physical memory available to hold the active working sets of all the running programs at the same time. Too many active processes may also be the cause. If the level of multi-programming is too high, the available RAM is split among too many applications, meaning no single program gets enough memory to run smoothly. Next is when the system tends to overcommitment of resources. The operating system allows too many programs to allocate memory at once, assuming that they won't all need it simultaneously. It's like opening multiple tabs or programs at once, causing RAM usage to spike and slow down the overall performance. And lastly, a poorly tuned virtual memory. It occurs when an operating system's internal algorithms for managing memory are inefficient or improperly configured, which can directly trigger or worsen thrashing. To best combat thrashing, the system can deploy a number of operation and tricks, only 2 of which will be discussed. The first move is the principle of locality technique. Programs naturally tend to reference data and code that are clustered together over short periods of time. The OS exploits this behavior to make intelligent guesses about which pages will be needed next, while also choosing which ones will be put aside. Next, it'll use the working set technique. By referencing the previous technique, the operating system tracks the exact pool of pages a process has accessed within a recent time window. Instead of guessing, the OS dynamically maintains only this active set in physical RAM. This precisely balances resource allocation, ensuring the process has enough memory to run smoothly without causing system-wide thrashing. A precise combination of techniques. One keeps track while the other handles the rest, working together at lightning speed in order to maintain balance and smoothness.